Okay, so for the first two questions that you have on Tuesday's homework of week 16, these are both examples where we're going to need to see complete sentences where you're explaining the difference between two different types of angles. In the first one, we're explaining the difference between complementary and supplementary angles. I'm not going to write out an answer, but I should see some sort of explanation that a complementary angle is equal to angles that total 90 degrees. Supplementary are two angles that when added together, they're next to each other, they equal 180 degrees. Moving over to adjacent and vertical, again, two really important vocab words that we need to continue with. Adjacent angles, and again, this should be in complete sentences, not shorthand the way I'm writing. Adjacent are angles that are side by side or next to each other. Vertical angles are angles that are across from each other. Now, it may be a good idea just to help. You may want to draw a picture just to show an example of complementary and supplementary, but I should see words. You may want to draw a picture that I explain the difference between adjacent and vertical, but I should see words, complete sentences. That means capitalization, punctuation, subject, verb, everything that's going to show that you know how to communicate these four vocabulary words. Okay, so we're going to go ahead and move down to vertical angles because problem number 3 is actually, I'm going to use my information I know about vertical angles to solve this. So because these angles are across from each other, they are vertical angles and they are equal to one another. Now this picture is not really very accurate because there's no way that this obtuse angle is going to measure 19 degrees, but we're just going to go with it and solve out. So because I know 4x minus 3 and 19 are equal to each other, I can create an equation. 4x minus 3 equals 19. I've now set up a two-step equation. I know the 4 and x needs to be the last thing that I separate. First thing I want to do is get rid of the minus 3. To get rid of minus 3, I'm going to add 3. And if I do it on the left, I also do it on the right. I'm now given a value of 4x is equal to 22. I'm going to divide both sides by 4. The 4's cancel here. I'm now left with the value of x is equal to 22 over 4. Now I can do several things here. I could simplify to x equals 11 over 2. I could also put this into a mixed number. X could also be equal to 5 1/2, or it could be equal to 5.50. Any of those are acceptable answers for x. Okay? Now, a scale, let's go ahead and over to number 4. A scale drawing of a room uses a scale of 2.75 inches to 5 feet. An object is 4 inches long in the drawing. What is the approximate length of the actual objects? Round to the nearest hundredths. We have students always forgetting that part. Now remember, for scale, I always have my model value is going to go over my actual value. So in this case, my model is 2.75 inches over 5 feet. It's asking me if an object is 4 inches long in the drawing, which lets me know that's the model. I can also check because it's saying inches, and inches matches up with the 275, so it needs to go on the top. I'm going to create a proportion. We know how to solve this. 2.75 times x and 5 times 4. 2.75x is equal to 4 times 5, which is 20. I'm going to divide both sides by 2.75. And when I do that, I'm going to use my calculator just to check my work. I'm going to have 20 divided by 2.75. It should give me an answer. Oh, it's one of these long numbers. 7.2727. And actually, it does not repeat forever. So I'm just going to go ahead and I'm going to round to the hundredths, which is this problem. Behind the 7, I have a 2. 4 less, let it rest. My answer will be 7.27, and don't forget your unit, my actual unit is feet. Thanks so much. Okay, go ahead.